Okay, so I assume everyone here is like developers or like interested in NFTs and trading NFTs and creating NFTs. So today we're going to talk about what Metaplex is, how it helps the Solana ecosystem achieve its NFT goals, and yeah, see if we can get you guys building some stuff at some point. So we'll start off with who I am. Obviously, I mentioned myself. I'm Tony. I'm a DevRel at Metaplex. If you want to find me, you can always hook me up, ask me questions, chat to me on Telegram, find us in the Discord. I'm here to help you guys on board, and any questions or help you need, hit me up and we'll get you sorted. Yep, Tony Ball is most of my handles. So let's talk about what Metaplex is and what it does. So Metaplex is the underlying protocol and infrastructure that powers the ability to use NFTs on Solana. So it started out a long time ago, probably about 4 years ago now, maybe 25, maybe in 2020 or 2021, a program called Token Metadata came out. And it allowed SBL tokens on Solana, which is like the native token system, to start storing metadata, such as name and images and bits and details and stuff like that. So this was adopted for the NFT standard. And basically every NFT on Solana that you probably see or you've got in your wallet probably interacts with our program. As Mark mentioned, like 99% of NFTs on Solana come through our protocols. We're basically like the ERC types and standards, what you would find on ETH. We are that on Solana. So the program that started it all was token metadata, as mentioned. It was the original program. Token metadata NFTs were basically SBL tokens with a supply of one. That's what makes an NFT. It's a token which has one value. So you can only trade that one token or coin, as it would be. That would be the NFT. And obviously an NFT is locked. The mint authority is locked. So you can't mint more tokens, because if you mint more than one, it's no longer a non-fungible. It's a semi-fungible. So NFTs are one token and one token only. Token metadata stores both on-chain and off-chain data. This was to save space and to save funds for users. So we have on-chain data such as name, and we have something called a URI or URL, which points to the off-chain data, which houses a bit more detail, stuff like attributes and bits and pieces like that, which are too expensive to store on-chain at the time. Has anyone here, through Reactions, used token metadata before? Have we got any users that have done NFTs? Maybe not. Okay. So that's the program that started it all. And then the secondary program that helped start all this and make NFTs popular on Solana was something called Candy Machine. Candy Machine is a very popular program on Solana, which allows users and projects to basically market and present their project for sale. You load all your NFT data into a Candy Machine. It's like a gumdrop machine, basically. And a user will come along and pay however many Sol to mint an NFT, and the Candy Machine will deliver a random NFT from all the NFTs you've loaded into the Candy Machine. So let's say I load 10,000 NFTs into a Candy Machine, I will get one of those random NFTs, and that's what made Solana very popular for NFTs. The cool thing about Candy Machine as well as being a distribution method, was it allowed lazy minting. I originally came from an ETH background, and with ETH and NFTs at the time, it's probably changed now. It's been years since I've been on ETH, but you had to pay up. The project had to pay up front to basically store and mint all these NFTs. Where Solana made it popular to lazy mint. So lazy minting means you don't create all the NFTs at once. You basically just upload the data, and when a user mints an NFT or purchases an NFT from the Candy Machine, it actually lazy mints at that point in time. So the cost of actually distributing NFTs is actually spread out between all the purchasers rather than the project owner. That's quite a powerful thing. Sorry, where are we? Distribution. So token metadata has been the standard of NFTs for the last 3 or 4 years. Last year, actually about this time last year, we actually developed a new standard for NFTs called Core. The problem with token metadata was it was starting to get very expensive for users to make projects and NFTs. It was difficult upon the program side to do coding. And yeah, it was basically just a lot of baggage and a lot of tech debt that we needed to sort out and clean up and make things a little bit quicker and cheaper for users. So Core is a NFT standard that we built that is basically a simplicity first approach. What that means is we basically just taken a lot of stuff and stripped it all out. So token metadata had too many accounts. It wasn't very composable. It was hard to do dev-related things with it, transaction sizes and stuff. Tried to do too many things at once. Token metadata was for fungibles, it was for non-fungibles, it was for programmable non-fungibles. Integration baggage for developers was hard, and then the tech debt as well, which I mentioned. Core stripped away loads of different things. So originally, when we had PNFTs, for example, we needed 1, 2, 3, 4, 5, like up to 6 different accounts just to be created, just to store NFT data. That was too much. We had to pass all these accounts into the program instructions to actually like do transfers or do burns. So this became like quite a strain on like transaction sizes. So we've gone from these 5 accounts, which was a metadata account, a master edition, we had a token record, we had a mint, and we had a token account. These two actually came from SBL token account. And then we've gone from that, with Core, we've gone down to one single account, which is much better. And it stores all the key information we need, like a key, an owner, an update authority, the name, the string. And yeah, that just improved things dramatically in regards to like costs and CU and transfer. So we've gone from 5 accounts down to 1 with Core. The cost per mint has gone from 0.22 down to 0.037, which is nearly a 10x cheaper to mint. So we can see here, cost per mint per 1,000 was 22 SOL. If a project was to mint all the NFTs themselves, it's now dropped to 3.7 SOL. And mint CU, if you're not sure what CU is, it's compute units. It's like, think of it like how much processing happens on the Solana validator to actually process a transaction. So we dropped from 205,000 to a mint down to 17. And transfers dropped from 195,000 down to 25. So this alleviates some of that traffic and validator compute unit usage that basically all token metadata NFTs have to go through. So we're trying to bring down our tech debt on the ecosystem as well. Yeah, so is any questions so far about those?
No, but I think it's very, very efficient now in Core. How much scale is that?
What do you mean by scale? Sorry.
Like how much cheaper is that?
It's close to 10x. It's like I think like around 9 point something. It's close. It's 3 for 7 down. Yeah, from 2.3 down to 3.7. So yeah, it's close to a 10x cheaper to mint for users as well. So obviously, if I was purchasing from one of your canning machines, I would have to pay this rent cost for the NFT, which is probably like close to $2 or $4 at the moment. Where if you're minting a core project to your users, it only costs them 0.0037 SOL, which is close to a couple of cents now. So it's a lot cheaper for your end users to actually mint from Core as well.
Don't I get a question real quick?
Yeah, sure.
Yeah, the Mint CU, by the way, it's Korean. The Mint CU and Transfer CU, is that lower? Is that the lower the better, or is it something that is like compromised due to the lower cost?
It's actually lower the better. So the Mint CU, think of it like how much processing needs the computer needs to actually do a transaction. So it would need 205 compute unit cycles to actually process a transaction, where it only needs 17,000. So we can actually fit in what's that? Probably like 15x. Is that 15x, 10x? And my maths isn't great. So we can actually fit more CU cycles into a transaction before we run out. Because obviously the base CU cycle is like 400,000 for a transaction. So you can actually fit like more transaction in. You can do more with your actual transaction on the validator before you run out of like compute units. Because obviously if everyone had unlimited compute units, everyone would just like use all the validators and No one else will be able to use them.
Got it. So there's no trade-off by having all these like kind of like upgrade, right?
Yeah, it's an upgrade. So basically, this is basically code efficiency. So
All
our
right.
code efficiency has gone from like 205,000 compute units down to 17. So we're using less of the validator to actually get a transaction done.
Got it. Thanks.
Cool. Anyone else? We can move on. We'll move on quickly. So we'll talk about assets quickly and what Core can do compared to token metadata. So assets themselves, I'm going to run through this quickly so you have limited time. They're a single account design now, as mentioned. They just take like this is the state of an asset. I don't know if any of you are familiar with Rust or on-chain programs. So we have a key, an owner, an update authority, and the basic two metadata structures, which are a name and a URI, which has been carried over from token metadata. And for space efficiency, we've actually like combined where token metadata had its own collection of fields that took up like 32 bytes. We've actually combined the update authority to become either the update authority or the collections. We've like multitasked some of these parameters, which is great for like space saving and CU as mentioned. Collections, I don't know if anyone's used token metadata before, but collection NFTs themselves used to be like actual NFTs, so it got quite confusing. So they appeared in your wallet, and occasionally like developers and people, especially new users, would be like, oh, what's this NFT in my wallet? I don't recognize it, and they would delete it, and that would actually be your collection NFT. And if you deleted that or burned it, that would actually break some of your functionality, because to do some transactions you would need to have a valid collection. So now collections have been stripped away. They're no longer like NFTs. They're like their own thing. They don't get stored in wallets, so there's like less breakage, which is quite nice. The cool thing about these new core NFTs are plugins. We have a plugin system. So this allows you to add these little bits of data and plugins to an asset, which makes them behave differently. Like you can make them behave how you want them to behave. Where token metadata was quite rigid, there was like 4 different lifecycle hooks you could create, you could burn, you could transfer, and you could update. That's kind of it. You didn't have much control over those. Now with plugins, we have all these different. Let me grab a list for you. We have all these different plugins which do different behaviors. So on an LFT, for example, I can add a freeze delegate. So a delegate basically means I'm allowing someone else to do an action on my behalf. So let's say I make a project. A way to do escrowless staking now would be I delegate the freeze authority to the escrow or the program, and they can freeze the NFT on my behalf. So that means we can do like escrowless staking, transfer delegates. These are quite good for like, and the burn delegate are good for like gaming. So let's say a character I'm fighting against, or my character dies in a game, the program or the game can burn my NFT like as is. I haven't got to worry about that. And they'll just burn it, and my character's dead. Same with update delegate. I could delegate someone else to update the NFTs. Attributes plugin is a big one, which we'll talk about in a second. So that allows on-chain attributes now, which is something which is huge. Royalties is now a plugin rather than the data that used to sit on the token metadata NFT. It now sits on a plugin, and which is really cool now is we actually can put that on the collection. So it becomes a global plugin. So we haven't got to add royalties to every single NFT like we used to. We can now put it on the collection only, and that collection is now like has royalties across the whole thing. Permanent freeze and permanent burn are just like slightly more powerful versions of the freeze delegate. It means because normally when these are transferred, these get revoked. So if I was frozen, if I had a freeze delegate on my NFT and I transferred it to someone else, that freeze delegate would reset. With a permanent, it wouldn't reset. So for like a game, let's say I'm a game studio, I would mint my character to you. I would probably put permanent freeze, burn, and transfer on the NFT so that my program or game can interact with these NFTs at will. And let's say the character dies, I can burn it. Let's say it has some status effect on it, I could freeze it for a period of time, or I could transfer it to a user, for example, if it's sold. This allows games and studios to do more have more freedom basically with NFTs. Sorry. One of the good things about Core is we love to take ideas from the community. If you have plugin ideas or you think there's a functionality that Core NFTs are missing, you come up to us, you speak to us, you tell us what you want it to do, and we can assess the situation, and maybe we'll build the plugin. And yeah, if there's enough demand for it, we'll like expand the plugin system for functionality and use cases for the communities. We won't go through examples yet. I will take you through a code example. If anyone uses DAS here, DAS is pretty cool. It's like the indexing system for NFTs. Core is DAS ready. It's automatically stored on the indexes on all the RPCs, just the same as token metadata and CNFTs. So yeah, all that data can be referenced through DAS. And trying out Core, if you want to try out Core, there is a browser. So we've got this Core here. You can create some assets here on this very basic UI that we've made with all these plugins. This is at core.metaplex.com. I'll post all the links in the chat afterwards because I can't see the chat box right now, unfortunately. So if anyone's asking questions, I do apologize. I can't see those unless someone lets me know how to find them. Yeah, so you can check this out, play through here. It's got an Explorer on it. So you can see here all my assets. This is my test account. So you can see I've made a bunch of random stuff for like dev testing. And yeah, I'll take you guys through some code quickly just to show you how easy it is to make a core NFT. Is there any questions so far about that? Nope. We'll jump into coding. So core is actually quite simple. We will have our npm packages. We do have our own Web3 wrapper called Umi, which is something quite cool that you should probably check out. We need to use that for our programs because it's basically a client wrapper, and it also wraps around Web3.js. If anyone's used that, so you can head to our developer hub in DevTools, find Umi, and it'll teach you like how to install Umi. It's really simple. You just add a normal stuff similar to Web3.js, where you just pass it an RPC address, and then you have to register the program. So in this case, apologies. Oh. You have to register the programs. So in this case, oh, sorry. Apologies, 1 second. Have a drink. Oh. Oh, sorry. Yeah, basically you register the programs that you want to use. As you can see in this example here, we're registering token metadata and NPL candy machine. And then all the interfaces and handlers are here. So, what is a quick code example? I can't zoom in. Why can't I zoom in? We've got 4 dependencies, which are quite simple. We're installing NPL core. We have Umi. We have Umi bundle of defaults, which is the one you generally build Umi with. And for our data, we need to upload that to somewhere like Arweave or Pinata or somewhere to store online to reference. In this case, we're going to pull in the Umi uploader. Oh, I do apologize. Oh. So, simple. I've got a TS project. I like to use TypeScript. I'm just going to grab the needed imports from this test file that I made earlier, and we'll have a quick go through. Hopefully everyone's a JavaScript dev. Let's make a simple run folder, run function. The first thing we need to do is obviously import UMI, which is our client interface, and Web3.js wrapper. So that would be here. So what we have here, it is my keyboard shortcut for zooming is not working. Is that big enough for you guys to see?
Yeah, maybe a little bit more. So zoom in a little bit more.
What's the shortcut? My shortcut's not working. What's the shortcut for zoom?
Control plus.
Yeah, that's what I thought. Oh yeah, okay, it's working now. Okay, cool. Is that better?
Yep.
Cool. So what we have to start with is we'll just go through it piece by piece. Is we have the create UMI function. So this basically just creates the wrapper around Web3 and our programs, and then we just pass it in a RPC URL. In this case, I'm actually using Aura, which is a new Metaplex product which we launched back in Breakpoint, which is basically a indexer and a RPC service for Solana. So you can actually grab some free keys from here. If you guys head to aura-app.metaplex.com, again, I'll put these links in afterwards, and you can try out this RPC as well, and indexer for DAS as well. I've lost it. Yeah. Cool. So once you do that, then as mentioned, we need to register the programs we're going to be using. So as we're building a core asset here, core NFT, we're going to import and tell UMI to use the core program. So the .use NPL core. And because we need to upload assets as well, we also need to call on an uploader for UMI. So in this case, I'm actually going to use the Iris uploader, which uploads to the Iris gateway. And I'm just going to pass in the DevNet address to upload to. So that's UMI set up for the most part. We do have to import a wallet to UMI. So in this case, I'm going to load my wallet via JSON. That's just going to this test key pair that I've made here. So it's going to load that in. I'm then going to read the file into a secret key variable. I'm then going to umi.edsa, create key pair from secret key, pass in the uint8 array from that, and then finally we can tell UMI to use the key pair identity in itself. So when it sends transactions, it'll actually sign and send with this key pair. So if I console logged out this public key umi.identity.public key. Let's clear that. If I run that, you can see the UMI is actually referencing this key pair file, and it's giving me my public key. So it will automatically sign from this key pair as well. The cool thing about UMI as well is it has other identities you can use, like wallet adapter. So you can actually just pass in, like, if you've got Web3 wallet adapter installed, umi.use wallet adapter. Oh, I've not installed it. You have to install it, but it's a wallet adapter identity, and it automatically pulls in the wallet adapter, which is pretty cool. So it'll give you a pop-up for like users to sign the transaction. Once we've done that, we can then start the process of making this NFT. So the next part we want to do is we are going to upload an image to the Arweave and get the URI. So I'm just going to grab this section here. We'll talk about this. So uploading files with Arweave is actually quite simple as well, because we've done the uploader, and every uploader has to follow UMI's interface. all the syntax is the same for uploading to storage, whichever plugin you pick. So you can upload to AWS, you can upload to Arweave, you can upload to Iris, Pinata, etc. All through the same method. So the first thing we do is we grab an image file. I'm just grabbing my duck file here that I've just previewed and prepared earlier. So we're referencing the duck file as a file image, file path, and then we have to create a generic file for IMI. So we just call a create generic file function and pass in our unit 8 array of the buffer. And then to simply upload it, we literally just call umi.uploader.upload. And that's as simple as that. It doesn't really take much to upload an image. So if I do that, we should see here, if I run this code, we should log out. Let me actually, uploaded the image. So we know where we are. Watch it not work now. Oh, there we go. So that's it. Let's return our image gateway. We look at that, and that's my duck, which is fine. Cool. So now we've got our image and our URI. We can then move on to the next step, which would be uploading the metadata. Let's just grab that section. So we have uploading the metadata. So metadata on an NFT follows roughly the same standard for core token metadata and compressed NFTs. So you always have like an off-chain data with like name, description, an image URI. This is important. Your external website, for example. Your attributes, which everyone's mostly using, is like your backgrounds and like your hats and stuff, like monkeys wearing a red top, that sort of thing. So as we can see here, what we need to do is we need to populate the image with the image URI. So this is why we have to upload the image first. So we get the image URI. And then once we have that, we then stuff it into the image parameter. And that should give us an upload for the JSON. To upload the JSON, you can call the umi.uploader again and just type .upload JSON and pass it an object. And this will just literally automatically upload the object as a JSON file to the storage medium that you've chosen earlier. So in this case, Iris is going to upload this JSON file to Iris for us very quickly. So if I continue now, we should end up with two files. We get the image and we'll get the JSON file uploaded. Apart from I didn't log the JSON file. Let me cancel that. I can shorthand that actually, can't I? Yep. Cool. Let's run that. Do I run it? That's already running. Sorry. One sec. I need to restart because I've confused it. 1 second. Yeah, there we go. That's now basically got both our image and our JSON URI on the chain that we need for this asset. And if we visit this, we should also, yeah, it's placed our image URI into the image URI slot, which is what we need. So now we're ready to actually make this NFT. So the final step, which is the fun part, it's actually a very small bit of code. Is we actually create the NFT itself. Why? I placed it outside the function, that's why. Cool. Cool. The first thing we need to create an asset is a new private key, which is needed to sign the asset originally. This becomes like the asset address or the NFT address as it would be. Umi's got a really cool function called generate signer. And this will just basically just generate a new key pair and assign it a signer type key pair signer, which is needed for this asset. So to create a really basic asset, all we need to do is just to create, pass in our Umi instance, and then there's a create object, which if we have a quick look at that actually, we can call create args, which is a type of create v2. You can sort of see what we can pass in here if we want to. We can pass in the asset, which needs to be a signer, as we mentioned. If we're adding the asset to a collection, we just pass it the collection. We can change who the authority would be. We can change who would be the payer of the storage would be. We can basically set the owner when we're creating. So I could create this and assign the NFT to one of you guys, for example. Who the update authority would be. And then these two are just standard system program and log wrapper programs that need to be passed in. Umi is clever and it does half of this stuff for you by default. If you don't pass stuff in like the update authority, it assumes the person making the NFT is the update authority and the owner, etc. So because I'm not passing an owner in, because I'm not passing an update authority in, they're automatically going to be assigned to whoever is set as the identity of Umi, which is basically my key pair identity here. So yeah, we can see here, we've passed in our key, so this is going to become our NFT address, our name, so I'm going to call this my duck number 4. I'm going to pass in the JSON URI that we uploaded because that's needed for the off-chain data, and that's pretty much it. I can now create the asset, and to get the asset ID afterwards, I would then log out the public key, which is here, created asset public key. So now, with any luck, if I run this, we should have an on-chain asset. Obviously, if you've uploaded the image already, you don't have to upload the image each time, or the JSON, you can just put the URIs in if you have those. I'm just uploading them each time just for this example. Cool. So apparently this should have created this asset here. That's the public key that it's given me for the asset. So if I look at now the Explorer for core or SolScan or however you want to do it, I'm on DevNet. If I paste this ID in, I should have my duck number 4, and we have one asset. It's really quite simple. And the update authority is me. That's our key pair identity that put in. There's our gateway URI, our metadata URI that we passed in, and there's the metadata that we put up. Still got my background of red and my data. So that's pretty much as easy as that to make a core NFT on Solana. Is anyone got any questions about that?
Yeah, I think we have one. So thanks for that, Tony. I think we have one from the chat.
Yeah, sure.
From Renzo. How does collection verification work in core, and can anyone just add an asset to be a part of a collection?
That is a great question. So collection verification on core is actually done through a update authority. So the update authority of the collection. I mind if I've got time. I'll just make a collection quickly and show you. So let's do copy. So the great thing about this actually is because core create and the collection's actually similar. I've only got to change one item in this. I can just change from create to create collection. And it actually takes all the same arguments apart from an asset, which becomes a collection. I can then call this collection signer. Collection signer. Collection signer. Let's just get rid of the attributes. Let's call this my duck collection. And again, my duck collection. Let me create that quickly. It's just doing exactly the same process. Just uploading the image, the updating the metadata, and the collection. So basically, the collection has a update authority on it. For a asset to create into a collection, the update authority has to sign. That is the collection authority, basically. So when we come to here, when we do collection, I will need to pass in a collection object. So this time we'll do const collection fetch. Fetch collection. We'll pass in the collection ID in a second. But essentially, this OXOs, that's our new key for our collection. And this should hopefully, yeah. So now we've got a collection called my duck collection, and only the update authority can add items into the collection. So if I am not the signer of this, if I don't sign this transaction to add the collection when I'm creating the NFT, it will basically say unauthorized. So that's all going to happen there. Does that make sense?
Yep. Cool.
So if I wanted to add this to this collection here, for example, I would fetch. What does this take? Sorry, it takes a fetch collection. Takes the public key. So public key. Let me pass the collection in. Collection. Have to await that. And how it works is the update authority actually becomes the collection. So my duck number 4 in collection. I think that's under 32. 24, yeah. So if I make this duck now with this collection, you'll see that this update authority here doesn't become an update authority, it becomes the collection authority. So basically it's replaced. So there's no update authority technically on this this NFT now. The person who can update it would be the collection authority. Let's duplicate this and go forward 2. So that's our first duck. Let's put him in. Yeah. So you can now see here the update authority type is now collection. This is on the asset, and it's telling us that our collection is now this OXX. It's actually a pretty cool address, actually. OXXX address, which is this OXX here, which is our collection. So the actual update authority of this NFT becomes the authority of the collection. So the update authority of that asset NFT is this address. It's sort of it's like an inheritance system. Does that make sense? Cool. Any more from chat at all, or from speakers?
Yeah, that's all the questions for now.
Cool. Yeah. Don't know if there's anything else you want me to show, but that's kind of like how we make a collection and how we make NFTs and how quick and simple it is. Is there anything else you want me to demonstrate at all while we're here? Obviously, unfortunately, I can't make a candy machine because that would take too long. But
Yeah, of course. Yeah, I think Renzo, you can unmute yourself if you want to ask Tony directly.
Hello.
Hello, mate.
Am I audible? Hello.
you are audible. Yes.
Okay, this might be like kind of a backtrack to what you've already talked about, but I was just wondering, how does one proc the plugins to your Anchor program? Let's say I was trying to create a marketplace, and my Anchor program needs to proc the royalty plugin. How would someone do that? Like
Okay.
I don't see it in the docs. So I was just wondering.
Okay. So what we've got is it is in the docs somewhere. It's deserializing. Where's the docs? Up here. So if you head over to core, and I think guides, there is an anchor here, and there's how to. As a staking example here in the anchor guide, which I believe will show you how to. Yeah, it's gonna tell you here how to fetch the plugins from the asset being passed in, and it'll also show you here how to add the plugin as well, the freeze plugin for your staking or your marketplace. If your marketplace, obviously you want to freeze it in place, and you'd want to add the transfer delegate plugin as well. So when it's sold, you would then unfreeze the asset from the user's wallet and you'd transfer it out of their wallet to the new user. This would show you how to do that here. I can paste this afterwards as well. But it is in the docs. It's probably just a little bit hidden, unfortunately, is where our navigation is. You see, you've got a guide section up here for core. And there is somewhere a deserialization guide as well. Let me see if I can find it. CPI guide. Where is that? Unless we renamed it. Oh, deserialization. Deserializing assets. Rust. Anchor. Yeah. There's a deserialization part here in this Is this linked? Yeah. In this feature, there's a deserializing assets part in the core docs, which again can be done with Rust and Anchor as well. But again, if you're unsure about this as well, again, feel free to take my details and hook me up on Telegram, and we can go through it together. That's not an issue as well. Have we got any more?
Yeah, thanks. I was just really wondering how the plugins really work. So yeah,
Oh, how it
answered my
worked?
questions. Yeah, yeah.
Sorry. In what regards? Like, this is how to read them. So, what do you mean by how they worked? As in, like,
No. Now I understand how it works.
oh, okay.
Yeah.
If you wanted to add plugins as well, it's actually I'll show you how to add plugins as well. So you've actually in this create asset, you can order just plugins in this object quite nicely. Pass in an object. You can pass in the plugin type. Sorry, that should be an array. And then you can pass in an object of plugin types. You can do type. And if you're using TypeScript, you obviously then get all your different types of plugins, which you can add. So if I wanted to add royalties to this particular asset, for example, I can just type in royalties. I can then follow the. Sorry. And we get a second object of. Is it a second object? This particular one. Create plugin args, authority pairs. Let's check royalties. Royalties takes royalty args. So it will take a rule set and base royalties, basis points creators, and a rule set. Again, all these are in the docs as well. I'm just doing it through code. Basis points, so that'd be like your percentage. So 500 would be 5%. Rule set, we're going to set as none. I believe that's an option. Rule set, base rule set is none. Okay, so I need a rule set type. I'll do it the manual way. And then we're going to say creators. In this case, I'm just going to make it blank. And that would be a royalty, that would be a plugin. So you can just like fill out these details, which are all in the docs as well. So you can see a big list of plugins down here. Royalties plugin, for example. Gives you creators away, your rule sets, deny list, and then it gives you a full example of how to add that. So yeah, that's creating assets and collections and Metaplex core in general.
Right, thank you. I think we can get one more from the chat from Crayon. He's asking if are programmable NFTs similar to dynamic NFTs, and which one is more complicated to work on?
Dynamic in what way? Sorry.
Yeah, maybe Crayon, you can ask Tony yourself.
All right. So I've heard about dynamic NFTs probably 2 years ago. And what it does, it changes based on interaction on on smart contracts. Let's say an NFT that's being traded for a certain number of time, and it can actually evolve into something else. And then the old NFTs will be burned, and it will, turn into something else, right?
Yeah, so that would be program dependent, and you'd need to keep a way of keeping track of how many times it's been traded, but that would be done from like a custom program perspective. Yeah,
So-
that's not something like built straight into our products or protocols inherently.
Oh, I see. All right, all right. Well, thank you.
Yeah, so basically you'd be like tracking. So basically, I can explain how it would work. So like you would track through like a for a webhook or something from Helios or somewhere for her if it's been transferred. If it's been transferred X amount of times, maybe there's a cron or something in your backend that just sort of like realizes, oh, this NFT has been updated X number of times. Let's update it, change its data, and the update authority with the keys in the backend would sort of like do it automatically for you. That's kind of how that would work.
See, but how is programmable NFTs work actually? Because kind of like, I can understand what dynamic is, but the programmable, it's kind of new to me. I'm not sure if that's one of those NFTs that we can actually use for games or what.
So the PNFTs are from the token metadata programs. That's the older program. So you have NFTs, which are the original, and then you had PNFTs. So PNFTs were actually the response to the royalty issue that we saw on Solana. So when marketplaces started dropping all their royalties and not paying royalties to anyone, Solana needed a solution to fix that. We fixed that by creating programmable NFTs. So programmable NFTs basically have a block function on the royalties section of PNFTs, which is called the rule set, which is kind of what this is here, this rule set. We've migrated it across. So a rule set basically can deny programs from accessing or transferring NFTs. So let's take an example. Let's say my marketplace has decided to stop paying royalties out, and you don't like that. So you want to block my program from being able to sell your NFTs. You would add my marketplace ID to your block list. And that basically how we fix the royalty problem. Because if someone went rogue, or Magic Eden or Tensor or whoever decided to go rogue, we can add basically a block list to Magic Eden to stop them from being able to sell NFTs and only allow the marketplaces which are paying royalties to actually sell the NFT.
Oh, so programmable NFTs are actually just solving the royalties or the financial rule set of a certain collection. Is that right?
Correct. For gaming, what you actually got is to access gaming data and attributes on chain, because the off-chain data, which we talked about here, this JSON stuff, can't be read by programs. So these attributes are not available. What we did to fix that is we actually made an attributes plugin. So we've got type. I'll do this example quickly as well. Attributes. So attributes actually provide on-chain data. It's attribute list, array. Then we've got key value. Yeah, key value. Cool. So background red, etc. Let's do eyes green. So this data becomes available on chain. So I run this quickly. And I can show you a great example of this where there's an asset I made for a test asset for a backpack. I don't know if you saw the Twitter for that. Let me see if I can grab that quickly while it's making. If we go to here. Yeah, so Backpack are the first wallet to actually introduce the on-chain attributes. So you can see these ones here, this level of these chain icons. These are the attributes that are actually on-chain for the asset and that games can access within a program. So these ones can't be accessed by a program. These can, because they're the attribute plugin themselves. Did I just make that? I don't know if I just made that or not. Let's try it. Have a look. Yes, I did. Cool. So you'll see here we've got the usual stuff. We've got the duck, the off-chain data. So a program can't access this because it can't access the web to download JSON files, for example. But it can access plugin data. So we can see here we've now got a attributes plugin, and we've got key value pairs of background red and eyes green. So the programs can actually edit. You can basically, you can assign authority to these. So your program can actually edit these values. So that's exactly why I made this test asset for Backpack, because when, let's say, your character goes into battle with someone or levels up, you can actually adjust these via your program, these values.
Yeah, it's pretty interesting. I didn't know it can. So all this can actually be done through the Aura.
For anyone with DAS, any program will be able to deserialize all these data. You just pass the asset in, and the asset will, the program will just be able to read these values when you use our SDK crate.
Thank you. Sorry, I'm not really a dev, so sorry about
Oh, that's
these.
okay.
Yeah.
No, it's good information. No, it's good. A good question.
Yeah, appreciate it.
No worries.
So, Tony, just a question now. Will you be discussing about Aura, or is that all?
We can talk about Aura quickly if you want. So Aura is as I mentioned, it's a new DAS indexer and an RPC service that we're rolling out. You can pick up free keys. It's not a huge amount to talk about. We're still in beta. You can try it out. All the RPC functions should be working right now. The DAS function is working right now if people are using DAS. And you can grab some free keys at aura-app.metaplex.com and try it out for yourselves. But yeah, it was launched back in Breakpoint. It's been a fun, long journey with this to get it out to the public. So yeah, people want to start trying it and give some feedback to myself or the team in general, then yeah, that would be amazing. But essentially, yeah, it's just an indexing layer for Solana that we're trying to roll out and get everyone involved with. And yeah, it's not just going to be us either. It's going to be like an Aura. It's going to be hopefully with Triton and Helios and everybody else, and whoever wants to run an Aura node can run an Aura node. If you want to find out more about Aura, because I know we're running over time as well, is we got Aura on the developer hub. So this is a very key document which I'll post to you guys. Yeah, it's got all the features here. If you want to try it out, we've actually got a live. It took me a while to build. We have a live interactive. If I want to fetch a Solana monkey, for example, on Solana mainnet, you've got all your languages, Python. If any devs want to integrate into different platforms, so I can do JavaScript. I can like try it out, and it basically shows me the response data. And yeah, or is pretty cool. Maybe we should probably have a separate topic about that. Maybe, I don't know.
Yeah, probably because I think there's a lot of people here interested with Aura as well. Yeah, let's do that. Maybe next session. Anything else, guys? Before we let Sonny go.
Yeah, probably one last new question. So if ever a builder is working on Aura or something that is, Solana based, or Metaplex is Metaplex something that can actually work with other platforms or blockchain? How the interoperability of it? Let's say somebody wants to like do a project not just on Solana but also on Base or maybe I don't know, Abstract. Can actually, I mean, is that possible?
Yeah, so at the moment we can deploy to other EVM chains if we're asked to. So we are on Eclipse. So all of our programs are actually on Eclipse. So you can actually use all the same SDKs, and all you got to do is put in instead of putting in the Solana address, Solana RPC here, all you literally do is put in a Eclipse RPC instead, and that will then all work. All the programs are at the same addresses, everything's at the same address, so it's really like swap and play between like EVM chains and Solana. Sorry, not EVM, sorry, SVM chains, Solana Virtual Machine. So Eclipse is like a Solana Virtual Machine chain, and yeah, we can swap back and forth quite nicely. But you can't like transfer assets between the chains. There's no bridge yet. I don't know of a bridge, but like for the actual like creation process and like the program process, it's basically identical.
Got it. Thank you. That's all from me.
Yeah, I think we can go with another one. Not then.
Yeah, sure.
Renzo, do you want to ask Tony yourself?
Yeah, I think this is gonna be my last question. Does Metaplex does it do you guys have any grants for any emerging projects as of now? Or do you have
We
any
do. We do actually
grants?
have the. We're working with the Dean's List group, who I'm one of the. What do you call it? The authorities of actually, which we're giving out Metaplex grants for projects that are displaying use cases and exciting use cases for core. The grant is in LPLX. There is a. Oh, I'm gonna have to find that now. Let me have a look. See if that comes up. No, it didn't. Okay, I might have to find you the link afterwards. So it's going to be miles down my page. But there is a grants link for Dean's List. Oh, was that it? No. But yeah, there are some grants which are still ongoing, which I can get you the details for. For all the links, because I can't see chat right now, I'll post into chat. If everyone wants to hang around for 2 minutes afterwards, after I get off the mic, I will post all these links I've been talking about into chat where I can actually get to it. But yeah, I'll post you the link as soon as I find it. Here it is. That's in Japanese. You don't want that. Aha, there. So I'm going to keep that open because you want that. Cool. Yeah, I'll send that to you. But there is grants available.
Thanks.
Yeah, probably one last Tony. I'll take this chance. Yeah, because personally, I'm seeing a rise of other SVM chains, and for us, we're basically using Metaplex. So What would you suggest if there's an instance where we'd like to utilize that chain, but there's no Metaplex programs there? So, what's your suggestion?
I would say
We go
try and make some noise to the chain founders and get them to get in contact with us. I think that's probably the best bet, and we can talk about potentially deploying all the programs to these new chains. Yeah, but we
Okay,
are looking
got
to
it.
like get involved with the SVM community. It's just that we obviously need to make sure that there's demand for these programs and NFTs on that space. There's no point in us deploying to a chain which has got like 500 users, for example.
Got it. Makes sense. Thanks. Well, personally, I'd like to thank you, Tony, for giving us your time. And hopefully, we can do some more of these sessions in the future, probably with other topics.
Oh, I would love to.
Because just want to share that every time we teach people about Solana, there's always a portion there where we teach people Metaplex and NFTs. Is that? Maybe maybe we can have like an open cam where we can, just a groovy, perhaps a virtual groovy. You're keen on that?
I'm gonna stop screen sharing for a bit, but I'm gonna still be here. I think I can get to chat then. I can get to chat now. Yeah, nice.
You can share your camera, guys. So let's take a quick photo of.
I guess
one more.
gonna see me. Raiza is gonna see me. Oh my gosh.
If you're comfortable sharing your face, but otherwise, so good.
That's cool.
Thanks,
Oh,
Tony.
my camera's turned off. I'm just gonna turn my camera back on. We'll try to.
Yeah, I think that's all for now, Sony. Again, thank you in behalf of the blog and everyone here. So we're looking forward to build projects on Metaplex.
If everyone wants to hang around for like 2 minutes, I'll post some links for you if you want. But you can jump off
Sure.
chat if you want. I'll just start posting some links that I had.
Sure, Tony. I appreciate that. Thank you.
Thank you so much, guys.